Okay, so let's practice plotting points that are given in polar coordinates. Basically, we're going to start off by uh, placing our pole. So I'm just going to let this be my pole, and I need a little ray that is sticking out. Okay, so I've got my pole, and now I need my polar axis. So this is going to be my polar axis. And I believe I am ready to kind of draw in. I'm going to draw in little teeny tiny. So this is going to be r equals 1, r equals 2, r equals 3, r equals 4, r equals 5, and so forth and so on. All right, so I've got my polar axis up, my polar plane. Went a little crazy there. So now let's start off with 4 comma 270 degrees. So this tells me that r is equal to 4 and my theta is equal to 270 degrees. So I'm going to travel out until I get to the fourth r, right? So r equals 1, 2, 3, 4. And now I need to go around until I hit 270. So this is 90 degrees, this is 180, this is 270. All right, so here's my point. So this point right here, 4 comma 270, corresponds to, so let's put polar and then we'll put Cartesian. So 4 comma 270 degrees corresponds to, let's see here, 0 comma negative 4 in Cartesian, right? Okay. What about negative 2 comma 0? Okay, so I need to go, remember how we work with the negative numbers. If you have a negative r, you pretend like you have a positive r, you go theta, and then you flip it to take care of the negative. So the first step I'm going to do is I'm going to say, what is 2 comma 0? And now 2 comma 0 would be just to go out to r equals 2, right? But because, and theta is 0, so I don't get to travel anywhere, right? It's like I have to stay here at 2 comma 0. And because r is negative, I'm going to flip this over and I'm going to end up over here. Okay, so this is my, that is my point. So negative 2 comma 0 is the same as, look at that, negative 2 comma 0. Okay, let's look at the third one, which is going to be negative 3 comma pi. All right, so I'm going to go out 3. So go out 3, 1, 2, 3. I'm going to go out pi. Pi is to over here. And now because I have negative, I'm going to flip it to over here. So that is the point. That is the point, negative 3 comma pi. Okay, and let's see here. So negative 3 comma pi ended up being the same as 3 comma 0. Okay, what about 6 comma pi over 6? Let's pick a color for that. 6 comma pi over 6. So I'm going to go out to 6. So 1, 2, 3, 4, 5. Oops, I need to go out one more. It's like here's r equals 6. I need to go up pi over 6. So if this is pi over 2, this is pi. So pi over 6 is like take this and divide it with something like that. Right, so like here's pi over 4. So pi over 6 is going to be here. So I'm going to go out to 6 and up to pi over 6. This is my point here, 6 comma pi over 6. Now it's not so easy to figure out by inspection how the Cartesian coordinates, so we'll leave that for a little later on for our next example. So we've got that. What about 3 comma 90 degrees? 3 comma 90 degrees. I'm going to go out to 3 and then up to 90. So that's here. So that's the same thing as just 0 comma 3 in Cartesian coordinates. So 3 comma 90 degrees is the same thing as 0 comma 3 in Cartesian coordinates. And we've got one more, which is, oh boy, here's a doozy. This has got double negatives, so I need -2 comma negative pi. So the first thing I'm going to do, remember, is I'm going to ignore the negative in my r. So I'll have 2 comma negative pi, and then I'm going to flip it over the pole. Okay, so what is 2 comma negative pi? So I'm going to go out to 2, and then now to go negative pi, instead of going in the counterclockwise direction, I'm going to go clockwise pi. So if I go around, I'm going to end up here. Okay, so this point right here is 2 comma negative pi, but I need to flip it, right? So I'm going to flip it over here to get -2 comma negative pi. So -2 comma negative pi is the same thing as 2 comma 0. -2 comma negative pi is actually in the same location as the Cartesian coordinates 2 comma 0. Okay, and that's it. And now I like to, I think it makes it very easy if you have your circles, right? So if you got your pole, you got your polar axis, and you're drawing your circles to indicate r, the different versions of r, or the integer values of r. And then you can also put out some values to for theta, right? And it's a way of making it easy to figure out your location. So like that's pi over 2, that's pi, okay, that's 3 pi over 2, that's 2 pi, so forth and so on. Doing this is the same as if I say I want to lay out all of my x values. So x could be -5, -4, -3, -2, -1, 0, 1, 2, 3, right? And then I want to lay out my y values, right? 0, 1, 2. And so now imagine if I've got this grid, and I've got here, this is y equals 0, y equals 1, y equals -1, x equals 0, x equals 1, x equals -1. Now if someone gave you, so you could say, okay, here's my origin. And then if someone gave you coordinates 2 comma 3, you would say, okay, I need to go x equals 2, so let me go over to 2, and then y equals 3, so let me go up to 3, right? Whereas over here, if you had r equals 2 and theta equals 3, so you say, okay, well, r is equal to 2, let me go out to 2, and then theta equals 3. Since there isn't a degree symbol, that means 3, which is approximately pi, a little bit less than pi. So you say, okay, let me go out to a little bit less than pi, and there's my point.